Hi, my name is Bharat.
Hi everyone, this is Madhukar.
Hi, this is Palak Chugh.
Hi, this is Yuti Desai. Name of our language is Bumpy. It is from the initials of the team members Bharat Goel, Madhukar Raj, Palak Chugh and Yuti Desai. Feature of the language: Bumpy language is completely developed in Prolog. We are using top-down parsing technique here. It is a parsing strategy where one first looks at the highest level of the parse tree and works down the parse tree by using the rewriting rules of a formal grammar. We are using list data structure for both parser and interpreter as we are developing it in Prolog. Our interpreter is based on reduction machine and uses reduction rules. It is an imperative language and statically typed. It provides data types such as integer and boolean. It provides looping construct like while loop, decision control statement like if-else statement, and it is inspired by C language. Operators and constructs in Bumpy. We are providing basic arithmetic operators such as addition, subtraction, multiplication, division, and mode, assignment operator, comparison operator, greater than, less than, greater than equal to, less than equal to, not equal to, and equal to. For equal to, we are using colon, equal, colon, self-defined notation, and for not equal to, we are using tilde, equal to sign. Boolean operator, and or not. Primitive types bool and var, where var takes integer values. Decision constructs in case, condition, do, process, otherwise, process, and case. Iterative constructs when, condition, repeat, process, and repeat. The design flow of Bumpy language. First of all, the code written in Bumpy language will be input to the lexer, which is written in Prolog. It will generate lexemes like tokens on the basis of white spaces, new line, keywords, etc. It will be the input to the parser, which is also written in the Prolog. It will give syntactic structure to the language. Then it will generate parse tree. The parse tree itself is an intermediate code as we are developing it in Prolog. Now the output of the parser, which is the intermediate code, will be input to an interpreter, that is our runtime, and it will execute and generate output.
Let me walk you through the lexical analyzer and parser of a language, Bumpy. The lexical analyzer of a language is written in Prolog definite clause grammar syntax. The definite clause grammar syntax helps to encode the language grammar as is. The input to the lexical analyzer is the source code. It generates a list of lexemes. We have written rules in a lexical analyzer that identifies the keywords, identifiers, numbers, special characters, etc. The rules also take care of the eliminating characters like spaces, tabs, new lines, etc. The output of the lexical analyzer is a list of tokens. These list of tokens are then fed to a parser. The parser of a language is also a DCG prolog code. The prolog generates the parse tree as its output. It uses top-down parsing technique. The parse tree of a code is stored in a separate file with an extension of .bmic. This file is stored in the same folder as that of the program code. Since we have designed a language wholly in Prolog, the parse tree so generated from the parser is actually the intermediate code. The generated intermediate code is evaluated using an interpreter in runtime environment. The interpreter actually evaluates each node of the tree by reading the parse tree from .bmic file. Now let's talk about the runtime and the interpreter. The runtime environment is basically based on the concept of the environment which is evaluated before and after any execution. The environment is basically a list of tuples. The tuple consists of key value pairs of the variables or the identifiers of a language and the value corresponding to it. We have written eval functions for each node defined in the parse tree, and the eval functions return an updated environment or an output value. After evaluation of the eval functions, the environments are updated. These eval functions are written using reduction rules to evaluate the code. So there are two rules that run on the environment. One is lookup, the other is update. The lookup predicate is used to look up an identifier with a particular value in the environment list, and the update predicate looks up for an element and updates the environment with the new value of the identifier. Language grammar. Language grammar starts with the start symbol parser and then breaks down into other non-terminal and terminal symbols. The comments in a language starts and ends with @ symbols. The blocks in a program starts with the start terminal and ends with the stop terminal. We have separated the data type with the variable names in our declaration statements. We have defined three types of processes. One is the assign process, the second is the control process, and the third is the iterate process. The control process corresponds to if then else in other languages, and iterate process corresponds to while loop in other language. We have also written predicates to read value from the user and print predicate to print the output or any expression on the console. In order to print an expression, we just have to write the show terminal and then the expression. To write a string or any other value, we have to enclose that value within asterisks. The expression evaluation also takes care of the precedence, where multiplication, division, and modular precedes over addition and subtraction.
I will show you how we have coded our interpreter, lexer, and parser. So here we go, and we can see that we have a source folder where we have compiler, where we have our interpreter and lexer parser, and in runtime I have created one file which is combination of these two. Now if you go to lexer parser over here, we can see that we have used this stream of tokens over here where we are taking tokens in and reading it from in stream, and then these tokens are passed through our lexer where we have defined all our keywords and symbols, like all the assignment operators, comparison operators, and all the keywords we are using to break the code into tokens. Now, and we have also seen handled all the white spaces, digits, number, uppercase, lowercase letters, and alphanumeric things. Now, in the parser, we can see that after the lexer we have parser, and in the parser we can see that we have these nodes which we are passing through each other. So when there's a parser, we are passing program node, and another program we are making tree over here and also passing the nodes we need. So if we have command, we have command node and block node, and similarly we are doing the same in the following. Like for the data types, we have data types tree, and we have data types like variable and boolean, and also we have like lot of processes which are our statements which can be assigned, control, iterate, print, or read. And here we have written all the rules for printing values and as well as reading values, and all the rules goes as follows. Now if we go to interpreter, we have all the rules to evaluate those. So you can see here we have similar program node which we are passing to create an environment and taking the final result in a env out. So like we have program node over here. Similarly, we have taken those nodes to evaluate. So, and also we have our lookup and update function, which is to look up the value in the environment and update the value in the environment. Also, we have evaluate all the functions like we have written before. So you can see all the nodes are there, which we are choosing to evaluate, and we are using the similar tree structure to evaluate because our language take parse tree to evaluate all these things. So for all the processes we have evaluated, and if you go to the, let's say, one of the expressions, so if the expression is for addition, we have evaluated that first we evaluate the term, and then evaluate the expression, and then we combine the result of by summing both and putting those output in the evaluate expression, which can be passed upon to assignment operator later on if we are assigning this expression value somewhere. So all our prolog is handling all those results coming over here, and we are properly handling everything through this. So for running this program, we have combined the lecture parser and interpreted into one bumpy.pl file. Bumpy is the name of a language, and we have combined the both of them. And on the top, we are opening this file and adding and creating an intermediate code as required, which is have extension .bmic. And then we are also then when the once the parse tree is generated over here, we are passing the parse tree through the parser, which in creates run the program, and then we can run the program finally. So for running the program, we just need to type bumpy and put the file name, and then we can go through our program as follows, and then it will evaluate, make the tree, evaluate the program, and then create the final output. And the output, how it works, it will be explained in the next part.
I'll be walking you through the execution process of our programming language Bumpy. I'm using superlog command line interface for that. The first step is to consult the runtime environment. After that, we need to enter the command to execute the program. Now I'm entering the command. So this command takes the path of the program file as an input, which I have already saved here. So after in entering the command, I need to execute it. So as I enter, you can see the execution program has started and is asking for a number to calculate the factorial. But before going any further, I want to show you that this command also generates the intermediate code. So as you can see, this is the file with the BMIC extension. This is the generated intermediate code. And as our programming language is in prolog, so it generates the intermediate code as the parse tree. I'll get back to the execution of the program. As you can see, the output of the factorial is 120. Let me execute another program, which is to calculate GCD of two numbers. As the source code location is same, so I'll just change the program name, and execute the command. So it asks for the first number, which I enter as 10, second number 30, and you can see the output of this is 10. And let's see the intermediate code for this program as well. So the intermediate code of GCD is also generated as a parse tree. So this was the execution process of our programming language. Thank you.